Well, let's take a look at these parent functions. P7 is just kind of a library of them. These are things that you should keep in mind, things that you should be looking for. A constant function, you've got f of x is equal to a, some random number. But the parent of that is an equation that is f of x is equal to 0. And the line looks like the black line that you can see on your screen. And the constant function is just a line that's going to go through the origin. It actually ends up being the x-axis. What then needs to happen is that we're going to take and we're going to do some transformations on these. So we're going to take and we're going to change this equation so that this line moves up and down and it moves left and right, and it does a bunch of different things to it. Okay, flips upside down, flips left and right, but this section is just on the parent functions. So in P8 we'll look at how we move those things around and what the equation looks like. A linear function, that's y equals x or f of x equals x. So it's a nice line, a nice straight line. So if you see a straight line, it's either a constant function or a linear function. Absolute value. If you see a graph that is a V-shaped, or you have an equation that's absolute value of x, you're going to create a graph that's a V-shape. And it'll always be that way. Okay? The parent of the absolute value is a V-shape that goes through the origin. When we take a continued look, we have a quadratic function. That's what we basically spent the whole year in Algebra 2 looking at. We've got y equals x squared, or some function with x squared. And then that x squared we're taking and we're doing some things to it when we're translating it and moving it around. But the parent, the original one, goes through the origin. This dot should go through the origin. It's off a little bit. It should go through the origin and then looks like a kind of a U-shaped. Then the cubic function again goes through the origin. That x cubed is going to look kind of a snaking area going down to the left and up to the right. That's the parent function of a cubic. And a square root, when we look at a square root, it's going to be half of that u shape of an x squared, but it's going to be off to the side. So when I take the square root function, the parent always looks like this. It starts at the origin, it kind of goes off and up to the right. Okay, so I get a square root of x. If you have that type of an equation, that's what the graph looks like. If you have this graph, that's what the equation is going to look like. So then we'll just continue with P8 here, because P8 is transforming those functions. And so if I have a couple different transformations of it, the first one being a vertical or horizontal shift, then if I'm going to do a vertical shift, I'm going to take and move things up or down. And so a vertical shift, if I do adding C, I'm going to move that upwards. So if I have, let's do all of these with different functions. So if I have a vertical shift on a linear function, then that's going to be y equals x. There's my parent, the linear function. And then I'm going to do a vertical shift. So I'm going to go up 2. Okay, so this is going to go up 2. It's going to be an equation. It's going to be linear because that's my parent, and then it's going to go up 2. The next one, let's do a square root. So I get y equals the square root of x. That's my parent function. And if I want to move it downward, let's say that I want to move it down 3. I just put minus 3 on the outside of the square root. Okay, so this is going to go down 3. If I want to do a horizontal shift, let's take our parent function of y equals x squared. Okay, if I want to shift this thing to the right, I have to change this a little bit. It's still going to be an x squared. Okay, there's my parent function still, but I'm going to shift it to the right, which means that I'm going to, let's move it right 1. Okay, and I'm going to subtract 1 on the inside. So on the outside, it's exactly what it says. If I have plus 2, it's going up 2. If it's down 2, it's minus 3. Or down 3, it's minus 3. But when I'm looking at shifting left and right, it's the opposite of what I would think. So minus 1 on the inside actually makes you think that you should go left, but it actually goes right. And inside is the opposite. So this is going to go right 1 unit. It's going to be an x squared because it's a squared function, but it's going to go right 1. Okay? And then finally, let's look at let's say the cubic one. So I've got a cubic function. Okay, there's my parent function. And then I'm going to move it c units to the left. Okay, let's move it 5 units to the left. So I've got plus 5, which actually makes you think you should move it to the right 5, but it's the opposite because it's inside the parentheses or inside the function, and so I'm going to move it left 5. So as we continue with this example, things that we want to be able to do are identify the parent function and identify the shifts. Well, in A, here's the parent function. The parent function is an x squared. Okay, so part A, the parent function is quadratic. Part B, I want to know what did I do with that quadratic? Well, I have a minus 4 on it, on the outside of that squared. So minus 4 on the outside, it is going to, I moved it down 4. Part B, I've got a cubic function here. Here's the parent, okay, with the cubed. Okay, so part A is cubic. That's my parent function for this. And then what did I do with that cubic function? I took that cubic function, I added 3 on the inside. So if I add 3 on the inside, I went left 3. And then I added 1 on the outside. So that means I went up 1. So I went left 3 and up 1. So this cubic function looks exactly the same as the regular cubic function, but instead of going through the origin, it goes left 3 and up 1, so it goes through negative 3 comma 1. Then part C, part A is they identify the parent function. Well, the parent function is the absolute value sign. So the parent function is the absolute value. Then I took that absolute value, instead of it going through the origin, I took and I subtracted 5 on the inside, which means that this went right 1. And so it doesn't matter what the parent function is, whatever I do to it, it is what's going to cause it to be the shift or the transformation that happens. Then the last transformation that we're going to look at, it's not the only one, but the last one we're going to look at is in a reflection in the coordinate axes. So reflections in the coordinate axes of the graph of y equals f of x are represented as follows. A reflection in the x-axis means that I'm going to basically be flipping this graph upside down. And so I'm going to take whatever that parent function is, okay, in this case it's f of x, and I'm going to flip it upside down, which means that I'm going to put a negative on the outside of it. If I'm going to reflect it on the y-axis, then I'm going to take that parent function, but I'm going to put a negative on the inside of that parentheses, and that's going to reflect on the y-axis. And so again, you can use any parent function that you want to. Let's do a parent function at x squared. So I took that x squared and I just flipped it upside down. That's what the negative on the outside says. Okay. Let's do a cubic function. If I take that negative and I put it on the inside, that means that I'm going to be flipping that upon the y-axis, or I'm going to be reflecting it. All the x's on the right-hand side are going to become x's on the left-hand side. And so instead of this going up and to the right, it's now going to go up and to the left because I flipped it across or reflected it across the y-axis. So let's take a look at a couple of these problems here. For the following function, sketch a graph. Excuse me. Sketch a graph of each function for c equals negative 2, then c equals 1, and then c equals 2. Okay, and so the first thing that we should do is we should identify what the parent function is. So the parent function in here, it is right here. It's a quadratic. Okay, and so this is a quadratic graph. And so I know that the quadratic graph is going to go like this. And all I'm going to do is I'm going to, that side's off a little bit. Let me undo that. Okay. All I'm going to do is I'm going to take that quadratic and I'm going to be moving it around. Okay, so for c equal -2, I'm going to take f of x equals x minus a -2, and then plus a -2 on the outside. Well, I can rewrite that as x plus 2, quantity squared, and then minus 2. And so that the better way for us to look at this would be to say, well, I've got a plus 2 on the inside. That means that I'm moving this to the left 2, and I've got a minus 2 on the outside, so I'm moving that down 2. So this graph is going to go left 2 and down 2. So left 2 and down 2 gets me here. But the graph looks exactly the same. I didn't do anything else to the graph except move it. Okay, so I end up with this graph that looks like this. It's exactly the same graph, except I moved it. Well, let's take a look at c equal to 1. So I've got x minus 1 quantity squared and then plus 1. I've got a minus 1 on the inside. So minus 1 on the inside means that I'm going to move it right 1. A plus 1 on the outside means I'm going to move it up 1. So I'm going to move it right 1 and up 1. And the graph is then going to look something like this. It's going to look exactly the same, except that I moved it a little bit. And then finally, for c equal to 2, x minus 2 quantity squared and then plus 2. Again, I've got a minus 2 on the inside, so minus 2 means I'm moving it right 2, and then plus 2 on the outside means that I'm moving it up 2, so I'm going right 2 and up 2. This graph is going here. And it looks something like this. And all I'm doing is I'm just taking a graph and moving it around based on what I'm doing to the equation. Okay, that's called a transformation. And then finally, the last example, I want to use the graph to sketch the other graphs. And so things that I need on this graph, I need some key points. So I need to find out where these points are, where these corner points are, in order to do something, continue doing something with them. Okay. So all that's going to happen is that these points are just going to do whatever the transformation is. So in the first one, I have minus 2 on the outside of that graph. Okay, this is not one of our normal parent function, but it is a parent function. This is the original graph that we have. And now this says that right here that I'm going to move that down 2. Well, essentially all that happens is that each one of these points move down 2. So this point over here to the left was at -2, -3. So at -2, -3 was here, and then it's moving down 2 spots. So I just move it down 2. So it's still at -2, but it's down to -5 now. The second point as we continue to the right was at 1, 1. Well, I'm going to move that down 2. So if I move it down 2, it actually is going to be at -1, -1. The next point was at 1, 1. I'm going to move that down 2. It goes to 1, -1. The next point was at 2, -1. Well, I'm going to move that down 2 spots to get me to 2, -3. And then the last point I had was at 3, 0. I'm going to move that down 2 spots to get me at 3, -2. So the graph looked something like this. Went across, went down, went back up, and then it had a tail at this end and a tail at this end. And it should match exactly. You can do a better sketch than I can up here on the smartboard. It should match exactly the same, except that the whole thing is just shifted down 2. On the next one, I've got the only transformation that I have is a negative on the other side. Okay, so my y values are going to be the opposite of what they were before. So I've got this point -2, -3. If I'm going to reflect that upon the x-axis, which is putting that negative out front, then that point is going to go from here, and it's going to go all the way up to here. It's going to reflect on the x-axis. And you'll see it as we start plugging in these points that when it reflects, it's going to end up just being an upside down of what the graph was. So this point is going to reflect on the x-axis to here. This point is really the same point, just in a different spot to the right. So it's going to reflect there. This point is going to reflect once on the x-axis. And then this point doesn't actually reflect on the x-axis. It stays on the same spot because it was on the x-axis. So if you're standing on the reflection point, you don't actually reflect. So this graph looks something like this now. Whoop. Okay. It's the same graph, just upside down. And then finally, not only am I flipping that upside down in this one, so reflect on the x-axis, but I also have a -1 on the inside. So -1 on the inside means that I'm moving this left one. Okay, so I'm doing both of those things. So I have, let's just do this so hopefully we can see exactly what's happening. That's not what I wanted to do. So that hopefully we can see exactly what we're looking at here. Well, let me just rewrite it because I can't get this, and I'm not taking each individual part. Okay, so we have the same exact graph to the left-hand side, except that we're moving it to the left one. Okay, and so we're not only flipping this over, but we're moving things to the left. So the point that was here reflects up to the +3, but then it moves to the left one. So I'm at -2, and then I'm going to move it 1 to the left to get it to -3, 3. This point right here is -1, 1. I'm flipping that upside down to be at -1, -1, but then I'm moving that one spot to the left to be -2, -1. This point right here was at 1, 1. Flipping it upside down to get to 1, -1, and then I'm moving it left one spot to get to 0, -1. This point at 2, -1, flipped upside down, is at 2, 1. But then I'm moving it left one place, so I end up at 1, 1. And then finally, the point at 3, 0, flipping it upside down didn't really do anything. It's still at 3, 0, but then I need to move it left one to go to +2, 0. So again, the graph looks something like this, and you can draw it better. My smartboard's clearly off a little bit, but it's the same graph as the previous one that we just did, except that it's moved a little bit, shifted to the left one. And again, the graph that you see to the left is off a little bit because I had shifted around this stuff. Okay, so now you can double check that. The left-hand side matches exactly with the right-hand side, except that that we shifted it one spot to the left. So it did the same exact thing that we had expected it to do before, based on reflecting on the x-axis, which is the same thing that the bottom left corner did, but then we moved it left one, so it ends up at that point.